Composite figures, just the word composite, sort of, layman's terms means just to be made up of more than one thing. Composite metals, made up of more than one metal. Composite figures, made up of more than one figure. And these figures can be separated, right, into regions or pieces that are basic plane figures like triangles, parallelograms, trapezoids, etc. So to find the area of the composite figure, you would divide up the regions and find each area and then find the sum, right? That means we're going to add them together. The key way to know you're dealing with a composite figure is because you can't think of the name of the figure that you're looking at. So it looks like down at the bottom, we got ourselves a trapezoid, and up at the top, we got ourselves a rectangle. So I got area equals base times height for the rectangle, and area equals 1/2 times base 1 plus base 2 times height for the trapezoid. And we're going to take those two areas, we're going to add them together, and that'll be the area of our composite figure. Okay. So first things first, let's deal with the rectangle. I know that the rectangle is base times height. So here's the base, that's 23. Here's my height, right, connected by the 90-degree angle. I'm always looking for that. There's my rectangle. And you're going to finish that one off. Don't forget that that's square centimeters. So let's call that area sub 1. Okay, then for area sub 2, that's our trapezoid. That's going to be 1/2 times base 1 plus base 2. Well, base 1 is going to be 15 plus, where's base 2? Well, that's this piece right here. And that's going to be the same as up here, which is 23. So the trick is finding these pieces. Times the height. Okay, we have our straight up and down measurement. So if we were to come down here, let's see, if this piece is 12 and the whole thing's 18, well, 18 minus 12 is going to get us 6. So I think the height of the trapezoid is just 6. So get your area sub 2, also in square centimeters, and your final answer is going to be this answer plus this answer, the sum of the two in square centimeters. So what do we have here? Looks like we got ourselves a square in the center. How do I know? I see the 2 tick marks there and the 90-degree marks. So what's the length of the side? I don't know. I need this. So I move on. Looks like over here, wearing the red trunks, is a triangle. And I know that I have a height of 9.6, but I don't know the base. Again, if I were to look at that triangle like this, here's the 9.6, and I need that base. Down at the bottom, I got myself a trapezoid. Let's go ahead, we'll talk about the trapezoid in blue. Base 1, 10. What's the other base? Again, I wish I knew the length of that side of the square. So how do we get this base? Well, since I know this is an isosceles triangle, I know that this is also congruent to this piece. So let's focus on just this one right triangle. Couldn't you find the length of that side using the Pythagorean theorem? Yes. So, a squared plus b squared equals c squared. 12 is our hypotenuse. We're going to throw that out there. And we're going to have 9.6 squared plus I don't know squared. And let's do some arithmetic. I'll wait. And I get 7.2. So let's erase a little bit of this mess here. All right, that's a little better. Now I have this x equals 7.2. So that's right here, and that's also right there, which makes that whole length 14.4, which also makes this length 14.4. Now, if this whole show is 25.4, Then I guess 25.4 minus 14.4 is going to give us the height of our trapezoid, which is 11. And also, my other base is 14.4. So let's take it by color. First, the area of a square is side squared or base squared, so that's going to be 14.4 squared. Okay, that's our area of the square, area sub 1. For the triangle, area is equal to 1/2 times base times height, and that's going to be 1/2 times the base, this whole length, so that's 14.4, times the height from the base at 90 degrees, always go look for that 90-degree piece, times 9.6. I just want to get the decimals messed up there. It's already a little bit too sloppy, but you get the point. So that's going to be area sub 2. Area sub 3 is going to be our trapezoid, 1/2 times base 1 plus base 2 times our height, which is going to be 1/2 times 10 plus 14.4 times our height. I'll put in the little 90-degree, which is 11. Okay, and that's going to be our area sub 3. So find this, find this, find this, add them all together, and get a grand total area for the whole show. And don't forget that's going to be in square meters because it's two-dimensional space. How about the ice cream cone here? And this truly does look like an ice cream cone. Well, first, it looks like, right, maybe this will be Italian ice, lemon flavor. We got a semicircle on the top. A semicircle. So that's going to be area equals pi r squared. And we're going to take half of it. So area equals, well, it looks like 16 is my diameter, so that's going to be pi times radius would be, right, if 16 is equal to diameter, then radius is going to be equal to, whoops, I was thinking half, is going to be 8 squared, half of that. That's going to be our area sub 1. Down at the bottom, our area sub 2, this looks like a triangle. Now what's the problem? No height. We're going to have to figure that out using the Pythag theorem. A squared plus b squared equals c squared. So my base I know is the entire length across. So that's going to be 16, right? And at the end of this thing, we're going to have to multiply by 1/2. I'm putting the 1/2 on the back side. What's this height piece? Well, this is going to be an isosceles triangle, so we're going to cut this in half. There's going to be 8 and 8. And I'm just going to focus on the blue triangle. So it looks like that's going to be 8 squared plus b squared equals 17 squared. And when I solve for b, that's going to be the height of my triangle, and that value goes right here. Finish calculating for this, finish calculating for this, and then get a final area of your composite figure and put that right here, square meters. Now again, I'm not finishing the arithmetic because that's all it is. It's just arithmetic. You can finish that on your own. If we want to find the area of the shaded region, how about first we'll start by getting the area of the entire region, right? Or the entire figure. And then we'll subtract out what we don't want. So if we don't want the circle, we'll find the area of the whole square first, and we'll have what's left, right? So really sort of like, you know, big minus small equals what's left. So first, I notice that I have what seems to be a square. So area is equal to side squared or base squared. In this case, area is going to be equal to 25 squared. So the whole entire area is going to be 625 square feet. That's all of this. Okay. Now what we want to do is we want to remove the circle and be left with just the gray areas. Okay. How do we find the area of the circle? Area is going to be equal to pi times radius squared. And what's the radius? Well, I know that this is the diameter, which is 25 feet, and half of that is going to be 12.5. So area is going to be equal to 3.14, or use the pi key, times 12.5 squared. I'm going to put this in parentheses so we don't get confused with the decimals. And I get that the area of the circle is 490 point, let's call it 63 square feet. So again, I have my area 1. This is the entire figure. This is the part that I sort of, don't want. So 625 minus the 490.63 is going to be the area of the shaded region, or A sub S. So 625 minus that last answer is going to give us approximately 134.38 square feet. And that's how we figure out area of the shaded region. Now again, if you use the pi key, you might get a slightly different answer. I think you get 134.14 square feet, but same difference. Okay, so what do we have here? Well, it looks like the big figure, the entire figure, is a trapezoid. And the part that we're removing, this part that we don't want, is a semicircle. Okay? And it looks like we really haven't been given the height of this thing. So if this is 17 up here, then isn't this 17, right? The whole distance is 37. Right? That's our whole distance. But this part right here is 17, leading me to believe that this part right here is 20. And now I have myself a right triangle that allows me to find the height. So a squared plus b squared equals c squared. And our height is the part that's missing. We know that 25 is our hypotenuse. So put 25 squared over here and 20 squared. And we're looking for the height squared. So go ahead and finish this one out. Check back in with me. You should have come up with a height of 15. Okay, so let's think about this now. We have the height is 15. The whole base of the trapezoid is 37. The top base is 17. That's that. That's our trapezoid piece. So area equals 1/2 times base 1, 37, plus base 2, 17, close that, times the height of 15. That's our entire figure, A sub 1. We're going to subtract A sub 2, which is the area of the semicircle. So that's, pi times radius squared. And the radius is going to be half of that height. So if the height was 15, then I think half of 15 is going to give us 7.5. And that's squared. So that's pi r squared. That's the area of a whole circle, but we only have a semicircle. So we're going to divide that in half. And we're going to subtract that answer and get ourselves a final answer, right? A sub c, the composite area, A sub s, the shaded region, is going to be the entire thing minus the part that we don't want, the semicircle, we'll say SC, gives us our final answer. So you come up with that final answer, and that's going to be in square inches. Again, whole trapezoid minus the semicircle gives us the shaded region left over. And that's essentially how we do this. You're just going to have to really think about this. It's going to hurt a little bit. You got to put some thought into it. You're going to have to reach in and use some of your math skills, the Pythagorean theorem and subtracting things, to get side lengths here and really think it through. Good luck.